This problem is asking us to classify the system of equations as either independent or dependent without graphing. So we need to find out what is meant by independent or dependent. So these are the two definitions I found. Independent system of equations. An independent system of equations is a system with exactly one solution. This is a point in the form of x comma y, which indicates the intersection of two lines. A dependent system of equations is a system with infinitely many solutions. This occurs because both lines lie on top of each other, meaning they are the same line. So we basically need to find out if these lines intersect at one point or everywhere. So to do that, I'm going to take each equation and write them in slope-intercept form, because that yields the two pieces of information I need to be able to answer the question. Namely, what's the slope in the y-intercept? So for this first equation, you can see that my slope is 9/2 and my y-intercept is 3. Let's see what we get when we do the same kind of work with the second equation. Now, I'm going to multiply everything by 2. That'll allow me to get rid of the fraction. And make my work a little bit easier. The last step is to divide by -6, leaving me with y is equal to 27/6 or -27/6, which, since 3 goes into both of these terms, reduces to 9/2. And -18 divided by -6 is +3. So the two things I should be looking at then are the two final equations. Notice that they are identical, meaning they graph the same line. They are on top of each other, or you could say they're the same line. So therefore, every point that is on one of the equations, every point that's a solution to one of the equations is a solution to the other equation. And since that's an infinite set, This has infinitely many solutions and is therefore a dependent system of equations. If the slopes had been different, that's when you have an independent system and then there is one intersection point. But these two equations are dependent.